The standard library provides a great number of algorithms, which take the form of functions operating on iterator ranges. The algorithms can be customized and combined to handle many common operations on ranges of elements. Perhaps the simplest of the standard algorithms is std4each, which takes an iterator range and a function and calls the function on every element in the range. In this example, we've got a vector named v and a lambda called printInt. We're using forEach to call printInt on every element in our vector v. This is a good example of what most standard algorithms look like in use. You give them ranges as pairs of iterators and predicates or operations as callable objects. We're not going to walk through every standard algorithm in this video. While they are all useful, there's over 100 and we just don't have the time. If you are interested in a video that covers most of the available algorithms in an organized way, check out Jonathan Bokera's 2018 CPPCon talk, 105 STL Algorithms in Less Than an Hour, which we'll link in the description. For now, let's take a look at an example that does a couple of interesting things using some of the standard algorithms. This is a longer example than we've done in most of these videos, but we're still going to walk through it one chunk at a time. The demo here is code that works with a deck of playing cards. So we start by declaring a card structure that holds a suit for the card and a value. There are some utility functions here for comparing and printing individual cards and vectors of cards, but we won't worry about the implementation of those for now. The real meat of this example comes in these four functions: generate deck, shuffle deck, draw, and cut deck. Each of these does something useful and common that we would do in real life with a deck of cards. The first function, generate deck, actually builds our deck of cards from scratch, and it does this using a few standard algorithms. First, we need to create a vector of cards called our deck that will hold the deck when we're done with it. Then we're going to create two arrays. The first array carries the values that any card can possibly hold, and the second array holds the suits that our cards can use. The number of suits is fixed and small, so we just lay those out with a literal array. But the number of values at 13, it becomes a little tedious to write all those out by hand. Instead, we use std_iota. This is a standard algorithm that fills a range with a consecutive series of numbers. In this case, we're filling the values array by giving it values.begin and values.end, and our sequence will start with the number 1. If we were to print out values, we would see all the values 1, 2, 3, etc. up to 13. Iota knows how many numbers to put in that range because it knows the size of the range. After that, we've got our array of values and our array of suits, and we just need to combine them into all the 52 possible cards in our deck. Unfortunately, there is no standard library algorithm that does exactly what we want to do here, but we can still use a standard library algorithm as a building block. In this case, for each suit, we want to loop through all the values and create a new card for each. So we start with a loop that will iterate over all of our suits, and within that loop, we're using std_transform. Std_transform can take an input range and an operation and an output range. For each element in the input range, it applies the operation and saves the result into the output range. In this case, our input range is our whole values array. We give it values.begin and values.end. Our output range is a back inserter into our deck, and our operation is a lambda that combines the suit that we're on and the value that we're on into a card object. So by combining these standard algorithms in this way, we've been able to construct from scratch a whole deck of cards. But of course, that's not the only interesting thing we can do with the deck of cards. Let's take a look at the next function. Shuffle deck is going to do exactly what it says it will. It's going to shuffle the deck. In this case, we can use std_shuffle. This is an algorithm in the standard library that takes in a range, and here we're giving it the entirety of our deck vector. And then it also takes in a random engine. I know we haven't covered the random utilities available in the standard library, but in this case, we're just using the default random device and random engine available from our library and passing that in to the shuffle call. You don't need to understand all the details to know that that's just going to be a source of random numbers that our shuffle algorithm will use to shuffle our range. And if we take a moment to look down at our main function, we can see that we're creating a deck with generate deck. We're then shuffling that deck and printing it out. And we see in this first block of output a shuffled deck of 52 cards. The next function we call is cut deck. This is going to take a deck and a position in the deck. Any cards above that position will get taken and moved to the end of the deck. This is a common operation that happens in a lot of card games. And conveniently, we can implement this with a single algorithm call. Because it turns out cutting a deck of cards is the exact same thing that stood rotate does. It takes the start of a range and the end of a range, and then it takes a position in that range that we would like to be the new start. It takes all of its arguments as iterators. So to get the position iterator from the integer that was passed in, we simply take the begin iterator and add position. And we can see the results of this in our output. Notice that these are the first 6 cards in our deck after the shuffle. Then we call cut deck with 6, and we see the same sequence of 6 cards is now at the end of the deck. The rest of the deck has remained unchanged and is just shifted up to fill those 6 slots. The next thing our main function is going to do is draw a hand from the deck. So we have a draw function that takes in the deck we want to pull from and the number of cards we'd like to draw. In that function, all we're doing is creating a new vector to hold the hand that we're drawing, and then we're going to copy n of those cards from our deck and insert them into our hand. In this case, copy n takes its input range as a begin and a count instead of a begin and end. You'll see a handful of algorithms in the standard library that have this _n suffix and work in a similar way. After we've copied the cards we want to draw, we need to remove them from the deck. So we call deck.erase and we give it a range, again in the form of iterators, and this range covers all the cards that we just withdrew. And we can see that when we call draw, the hand we get is, sure enough, the first 5 cards in our deck after it was shuffled and cut. Now, not all of the standard algorithms modify the sequence that we give it. Some of the algorithms answer questions about the ranges that we give them. One good example is max element. So let's say we want to know what the biggest card in the hand we just drew was. Well, we can use stood max element. We give it the range. In this case, it is our entire hand using begin and end, and it returns an iterator to the biggest card in our hand. Here we can see that given this hand, it identified that the biggest card was our Jack of Hearts. And speaking of hearts, what if we wanted to just filter our hand to find all of the hearts cards? Maybe we're writing an AI to play some card game and we know that the next move requires a card with the suit hearts. Well, several of the standard algorithms allow us to provide predicates that filter which elements they work on. One example is copy if. This will take an input range and an output range and a predicate. Anything in the input range that matches the predicate, where the predicate returns true, will get copied into the output range. So here our input range is our hand, again using hand.begin and hand.end. Our output range is another back inserter, in this case on this new vector, hearts cards. And our predicate is a lambda that takes in a card and returns true whenever the suit of that card is hearts. Then when we print out that vector of cards, we can see that it successfully grabbed all of the cards with the suit hearts from our hand. In this case, that was just that Jack of Hearts that we saw earlier. I know this has been a bit of a whirlwind tour of this code example, but the point here is to just give you a taste of the breadth of algorithms available in the standard library. And even still, we only touched a small fraction of what the standard algorithms can actually do. The standard algorithms are important because they give us a common vocabulary to talk with other C++ developers. They let us focus on what we're trying to do to a range without worrying so much about how we're doing it. There's a popular guideline in parts of the C++ community introduced by Sean Parent called No Raw Loops. To oversimplify this guideline for a moment, it encourages you to reach for algorithms instead of building everything from scratch with loops. If a standard algorithm doesn't already exist for the thing you're trying to do, consider writing your own generic algorithm to solve the task instead of a specialized loop for that one instance. In the next video, we'll take a look at how to do just that.